Hello, so in this video, what we're going to be doing is going through the interview question is unique. And this is a string related interview question, and it can be found on page 90 of the book Cracking the Code Interview. And it's a fairly simple problem. So the problem says implement an algorithm to determine if a string has all unique characters. And it also has a second part that says, what if you cannot use additional data structures? So, for example, we have this string right here, and what we want to test is that each character is unique. And as you can see in this one, it's not, because we have two J's, we have two T's. So we need an algorithm to find this out. We're going to be solving this interview style. So we're going to be going through the process right here. And so the first thing we want to do is we've looked at the problem. It's fairly simple. The second thing is an example. So we don't have an example, but we're just going to be going with this one. And the next thing that we're going to do is we're going to come up with a very simple, straightforward brute force solution. This is the most obvious solution, but it's not necessarily the best. So the brute force solution that we're going to go with is simply go through each of the characters, so X, Y, W, etc., and then compare it to every other character. So start with X, compare it to each of these. If we find another X in here, we can return false because we know the string is not unique. And then once we reach the end, move on to Y and do the same. So I'll show you a quick trace of how this works. So X, Y, W, J. I'm just going to write out the string here. X, Y, W, whoops. X, Y, W, J. And what was the other character? T, J, A, Q, H, T. T, J, A, Q, H, T. So let's start off with X, and we'll look through Y, W, J, T, J, A, Q, H, T. So X doesn't exist twice, so we can move on to Y. Look through W, T, J, A, Q, H, T. Y doesn't exist, so we can move on to W. W does not exist in the string either, so we can then move on to J, and we look here and then we find another J right here, so we can return false. So this is the brute force method. So if we were to look at the code for this, so firstly we'd be returning a boolean, so bool would be the return type. Method, we should just call it whatever the name of the problem is, so we're going to go with is unique. We're going to take in a string S. So S would be a string like this. And so the first thing we're going to do is we have to go through each of the characters in the string. So we can have some kind of for loop here. So for I equals 0, I is less than S dot length, I plus plus. And what we can then do is we can select a character. So let's say the first character here would be X, and we can assign it, I guess, to a character variable. So rc equals, and then we can just say the value at index I. So index 0 would be X, index 1 would be Y, index 2 would be W, and so on. Then what we want to do is we want to look through the rest of the characters. So if we were at X, we want to look through the characters from Y to T right here. If we were at W, we'd want to look through the characters from J to T and so on. So we have another for loop here, and we're going to have J. These are ints, by the way, kind of obvious. And we want to start with the next character, remember. So if we were at X, we want to be starting from Y. So we want J to start from I plus 1. Again, we want to run as long as J is less than the length, or up to the last character, this basically means. and we want to do j++ again. So we want to increase j each time. And what we want to check here is if sj, so the character at j, is equal to c, so this character that we selected right here. So for example, if we were looking through x, if each of these characters was equal to x, then what we want to do is we want to return false right here. And we can close this one off. So we check if the characters match, if they do return false. And we'll do this for every character, every other character. And we want to do this for each character. And if once we look through each of the characters and none of them have duplicates, we can return, running out of space here, we can return true here, and we can close off the method right here. Now, if we think about the space and time complexity, so let's talk about time complexity first. Here we will be looking through the entire string. So this would be order s, where s is the length of the string. This right here, we're accessing a single character from the string, so that's always constant time, so order 1. Here again, we're looking through the characters in the string, so this will again be order s, where s is the length of the string. And here we're doing a comparison, but it's only of one character, so this will be constant time. The length of the string doesn't matter. And yeah, so that's our time complexity. So we can ignore the constants, which we always do. So here would be doing order s, and because it's inside this for loop, we'd be doing for each of these s's, we'd be doing another set of s. So it would be order s multiplied by order s, which gives us a time complexity of order s squared. If we think about space complexity, the only extra space that we're really using is this character here, and that's a constant. It always takes the same amount of space to store one character, and it doesn't grow depending on the length of the string. So our space complexity is just order 1. Again, remember, this character gets destroyed on each iteration of the for loop. So that right here is our brute force solution. It's not very efficient, of course, but it does work. It is a solution. So we at least have that. So we can mark that down. So the next thing we're going to be doing is seeing how we can optimize this. So we have a bit of a few things that we can try. Firstly, any bottlenecks. I guess we don't really have any bottlenecks here since we have to look through all the characters anyway. We're not doing any unnecessary work really either. If we look for duplicated work, yeah, I guess so. One thing that we can do is we can see that we have this s.length right here. Let me go to blue for improvements. We have this s.length right here. So what we can do something like is we can say int sl equals s.length. And then we can change this and this to use sl. It's a very minor improvement, but I guess it's duplicated work. And then we can look through these. So look for any unused info. The only unused info that we have is this about what if you cannot use any additional data structures. We're not using any data structures, so that doesn't apply here. We can try solving it manually on an example. So this means, how would I go about solving this as a human? So we can try doing that for the same string that we had before. So the way that I would do this is, if I write out the string again, x, y, w, j, t, j, a, q, that's an a by the way, h, t. I would personally just keep track of the characters that I've encountered so far in some kind of a list or data structure. So for example, I'd look through each of the characters and I'd have a list right here, or a map or something like this. So I would look at the character, check if it's in the list, if not, add it. So I'd add x here. Y is not in the list, so I'd add y. W is not in the list, so I'd add W. J is not in the list, so I'd add J. T is not in the list, so I would add T. J is already in the list. And if I find something that's already in the list, I would return false. Otherwise, if we reach the end of the string, we can return true because we know there are no duplicate characters that we encountered twice. So that's how I would do it if I was given this problem. And we can probably make use of this in some way. So that's something. And the next thing we can think about is making a space versus time trade-off. So we can think if we were allowed to use some extra space, how could we reduce the time? And this is something that we can see happening here because we have this extra space for this list of sorts here, but we're actually saving time because we're only going through each of the characters once. Here we were going through each of the characters, and for each character we would go through every other character. But here we're saving significant time because we're only going through each character once. And what we can do is we can use a data structure essentially to do this. So that's what we're going to be doing in our next optimization. So what we can do is we can make use of a kind of data structure that has a lookup time, a constant lookup time, like a hash map, for example. So let's see how that would work. So again, we have the same type of method. So here's unique. It takes in a string S. And the first thing we're going to be doing is we're going to be setting up a map. So what we can do is we can set up a map. So let's say a hash map, for example. And I'll call it SM string map equals new . Actually, you know what? I'll just make this simple. Let's say hash map SM. I'll just declare it for now. And it's going to have strings as the key or character. Let's say character. And it could have anything as the value, but I'm just going to go with number. So what we're going to be doing is we're going to be following a similar process that we did here. Instead of storing it in the list, what we're going to be storing is we can just store true, but I'm going to just store the index that I found the character. So here, for example, I would have stored 0. I would have stored 1, 2, 3, 4 like this. But you can store anything here. All we need to do is make sure that there's a key in the map. So right here. So again, we're going to have to go through each of the characters at least once. So we can have a for loop here. I equals 0. I is less than s dot length. And then I plus plus. And what we want to do is we want to firstly access the character at index I. So we can say something like char c equals si, like we did before. And then the first thing we want to do is, like we did here, we want to check if the list has that character already. So, or the map in this case. So we can say if sm.has or contains whatever the method is in the map implementation, character C, then we want to return false. So if it already exists, and we can close this off right here. Otherwise, we don't need an else statement here because we're returning here anyway, if this is true. Otherwise, what we can just do is we can say sm.insert. So we want to insert into the map. And we can insert the character as the key. And we can, like I said, we can store whatever we want as the value. We could have stored true here, but we've put number here, so I can just insert the index where it was found, like this. And we can close off this for loop. So once we've iterated through every character and we haven't found a duplicate, we can return true right here. Whoops. Return true, because the string is unique, and we can just now close this off. So let's check through this again. So we created some kind of data structure. We go through every character, we check if it's in the data structure. If it is, return false, because we've already encountered that character. If not, insert it. So yeah, fairly simple method. So if we think about the space and time complexity now, creating this right here will take constant time because we're not putting any values in it. We're just setting up the data structure. Here we're going through the length of the string. So this would be order S, where S is the length of the string. Here accessing a single character once again is constant time, so we don't have to worry about that. Now in a hash map, it depends on what data structure you use, but if we're using a hash map, the lookup time of hash map is always constant because we calculate the hash, we find the index of that hash, and we access it straight away. So this is a constant time. It doesn't matter. The length of the string wouldn't make a difference here. And also inserting into a hash map right here is also constant time because once again, we calculate the hash and then at the index of that hash, we insert the value. It's also constant time. So our time complexity now is, if we ignore the constants, is simply order S right here. So it's just the length of the string. If we think about the space complexity, it can vary, especially if this hash map can grow in size. But if we think about it, the maximum number of elements that the hash map can have is, as we can see here, for every character, we have the ability to insert it. So the maximum length that this can actually be is the length of the string, basically. So we can have as many values in the hash map as many characters in the string. So the space complexity here is order S. Sorry. Yeah, so this is a lot better than before, because before we had order S squared time complexity. So time complexity is improved. The space complexity has actually got worse, but generally we want to ideally solve for time more than space. So we made a time versus space trade-off. And if you think about the problem in itself, if we want to check that a string is unique, we're going to have to go through each character at least once, or at least almost every character at least once. So even in the best case, we would have to be looking through every single character. So unless we only have like the letters of the alphabet, in which case we can have a constant time of 26 or something. But yeah, but yeah, we're gonna have to look through each character once. So we've actually achieved, in terms of time complexity, we've actually achieved the optimal time complexity that we can have. Space we could probably improve upon, but this is, for me, in terms of time complexity, this is the optimal solution. So this is the one that we're going to implement. So we can store this as our optimized solution. And this is to do with using a hash map. So I'm going to be implementing this in TypeScript, but you could do it in any language really. So let's go here. So what we essentially want to do, trying to see if there's a way I can see both of these. Okay, so our method is going to be called isUnique. It's going to take in string S, and it's going to return a Boolean. So it's this part right here. So the first thing we want to do is we want to create a hash map. And in JavaScript and TypeScript, the simple map data structure uses a hash map internally, so we can just use that. So what we can say is const sm, like we called it before. I've got a little cheat sheet just to see how to create a map. So this is going to be a map that maps from character to number. In JavaScript, characters don't exist, so we just use string basically. And what we want to do is create a new map. So new map string. Okay, so we have our map. The next thing we want to do is look through each of our characters. So you could do the long for loop, but I'm just going to do for const c string s. This just basically means go through each character and set it to c. So it's basically this bit and this bit combined. Remove this. So what we want to do is we want to check if this map or hash map has the value. So we can say if sm.has, and we can give the character right here. So if it has a value for that character, then we want to return false. Actually, I'm going to change this out for a for loop because we need the index as well. So basically I've done this part right here. So if the map has a value for that character, so with the key of that character, then return false. Otherwise, what we can do is we can do sm.insert. Okay, it's not called insert. A set right here. So sm.set, and as the key we give the character right here c, so we can just do c. And for the value, like I said, we can store anything, but in this case we're storing a number, so we can just store the index I right here. And finally, if we've gone through each of the characters, we didn't find any duplicates, we just want to return right here. So then we're just going to do some quick testing. So what we can do is just do console.log is unique, and you can test with some strings. So I'm just going to do maybe 3 tests should be fine to start off with. So I've got some random strings generated here, so I'm just going to try it with these 3 to start off with. So if we just visually inspect them, the first one we can see we have MKLSERFOAZ, sorry. They're all unique characters, so this should return false. But look at this one. This is the one we had in the example. We can see that we have 2 J's, 2 T's, so this should return true. Sorry, this should return true. This is a unique string. This should return false. And here we can see that we have 3 W's and 2 U's, so this one should also return false. So let's try it. Demo. And we can see that we have this string is true, it's unique, this one is false, and this one is also false. So our method works. We can try doing some other things. So we can try giving an empty string here. We can try maybe one that has numbers. So we're going to have 7 here twice. We can have maybe one that has random characters. So maybe change this one. So this one should be unique. This one shouldn't be unique because we have 7 repeated, and this one should be unique. So let's try that again. and we can see unique, not unique, unique. So yeah, we have that right there. So I'm going to mark that as our solution. So we have our optimal solution right here. So let's move on to part 2 now. So part 2 says, what if you cannot use additional data structures? So as you know, we used a map here, which is an additional data structure. So this part asks, what if you can't use additional data structures? Well, we know that we have our brute force solution right here. This one has a space complexity, constant space complexity. We don't use any additional data structures. It's not an ideal solution, but in terms of time, but it is in terms of space, and it doesn't use any data structures. Let's try and get something in the middle right here. So maybe something that's better than this, but not as good as this one. And that's where we can use sorting. So some types of sorting, like insertion sort, for example, don't use any additional data structures. They do use space, it's not the same thing, but they don't use a data structure. So let's try and build something like that. So again, let me write out the example and show you how this will work. So I'm going to go with blue, purple, X, Y, W, X, Y, W, J, T, J, and A, Q, H, T. So first thing we want to do is we want to sort the string alphabetically. Now I'm just going to be using an online sorter just to make it easier. Okay, so we have a sorted version right here. So let's do that. So once sorted, this would be A, H, J, J, Q. So A, H, J, J, Q. And then it's going to be T, T, W, X, Y. T, T, W, X, Y. So how we go about in this algorithm is we'll go through each of the characters, and since it's sorted, we know that if there's a duplicate, the character will be right next to it. So for example, this J, there's a duplicate J, and it will be right next to it. Here we have T, there's a duplicate T, but it appears right next to it. So what we're going to be doing is going to go through each of the characters. I'll just show you how it works. So we'll start with A, and we simply have to check the character next to it, which is H. So H is not equal to A, so we can continue. H, and then J is not equal to H, so we can continue. Start off with J, we find another J right next to it, and we return false. So this is our method right here. Again, if we reach the second last character and the one next to it isn't a duplicate, we can return true. So that's the algorithm that we're going to be implementing using sorting. So again, it's going to be the same type of signature. So we have bool is unique. We have string S. So the first thing we're going to do is we're going to sort this. And you want to ask your interviewer whether you'd be allowed to sort the original string. If not, we'd store a duplicate string. So s.sort. Bear in mind, storing a duplicate string will use order S space complexity as well, but it's not using an additional data structure. So s.sort. So we've got the string sorted. Then what we want to do is we want to look through each character and we want to just go to the second last character here because we're going to be checking the one next to it. So there's no character next to this one, so we don't have to check it. So s.length -1, and then increase I. And what we want to check is if si is equal to si plus 1. So for example, for this H, we want to check if it's equal to the next index, which is J. Then if that's true, then return false. Else once we've looked through every character, the second last one, and we didn't find any duplicates, we can return true, that the string is indeed unique. So let's talk about time and space complexity. So something like, we could use something like insertion sort, for example, or quick sort actually. So this would have a time complexity of s log s. And here we're going to be iterating through the length of the string. So this is going to be order s. And here what we're doing is we're doing a comparison of one character, so that's constant time. So our total time complexity is order s log s followed by, so this is going to be a plus because we don't do this inside this loop, we do it afterwards, order s. And when we're doing an addition like this, we just keep whichever one's bigger, so it's going to be order s log s in total, which is still better than order s squared, but worse than order s. If we think about the space complexity, depending on the sorting algorithm you use, this can use up to order s of space in the worst case. So space would be order s. So yeah, this is our improved algorithm, I guess, that doesn't use any additional data structures. So we can copy that and paste it in here. And we can also code this one quickly as well. So let's go back to this. So what we're going to be doing is we're going to be sorting this string first. So I'm just going to be doing s equals. I mean, in JavaScript, the only way to sort a string alphabetically is to turn it into an array, sort it, then turn it back into a string. This is, again, it's n log n, because this one takes n, this one takes n log n, this one takes n. So if you join them together and add them together, it's n log n type, or s log s in this case. So again, what we want to do is we want to go through each character. So let I equal 0, I less than s dot length minus 1, I plus plus. And what we want to check is if si, or let's use the proper way to do this, the character at index I is equal to its adjacent character, then we want to return false. And then once we finish this for loop, we want to return true. So let's try it with let's try it with the strings that we had before. So this one, this one, and this one. Again, remember that we are expecting the same results. So this one is unique, this is not unique, this is not unique, unique, not unique, not unique. So let's run this. And we can see unique, not unique, not unique, unique, not unique, unique. So this method is also working. So I guess this is probably the best that you can have without using additional data structure. There might be better ones, but that's the best I can come up with. So yeah, that is our solution to the is unique problem. So we have an optimal solution with a time complexity of order s and a space complexity of order s. And we have, without additional data structure, our optimal solution will be time complexity of order s log s and a space complexity of order s. Yeah, thank you.